So last time I introduced the idea that everything lines up neatly, suggesting that it's an implication of the claim that perceiving is absorbing. So if perceiving is absorbing, then seeing is your eyes absorbing light waves and thereby creating a visual experience that matches the retinal image on your eyes. And since it matches the retinal images on your eyes, matches the object in the world. Hearing is your ears absorbing sound waves, your brain acting as a scribe to create an auditory experience that matches the sort of retinal image, the equivalent of the retinal image for your ears, the auditory image, which thereby matches the sound in the world, and so on all the way down. We then talked about how the McGurk effect challenges that by showing that, in fact, what happens to your eyes affects what you hear. In this video, we'll talk about evidence that what happens to your eyes affects your tactile experience, how things feel to you. So this is an experiment from two cognitive psychologists at Berkeley named Rock and Victor, and it shows that what happens to your eyes affects how things feel. So here's a box they created, and this is a box in which you can put various objects and a viewfinder that allows you to see those objects. Here's what object they've put in. It's more or less two-dimensional. It's a very thin plastic square, and the thin plastic square is fixed on a little pedestal to the bottom of the box. Now, this lens here is a distorting lens. It makes the object not look blurry, but instead look about twice as long as it actually is, or half as long as it actually is. There's various ways you could do it. Okay, so now someone comes along and looks at the object. The question is, what is this person going to see? Well, since the lens makes the object look, we're supposing twice as long as it actually is, she's going to see something like that. Now, in condition one of this experiment, you just have subjects look through the viewfinder, and remember that plastic square is in there. They look through with their eyes closed. And then this experimenter will say, which of the things I'm holding matches what you see? And what is the subject going to say? She's going to say, this matches what I see. Because since the viewfinder doubles the apparent width of the object, and the object is in fact this, she's going to see this. Now, you can also do this where you have the subject draw the thing and the subjects will draw this, but you get the idea. In the second condition of the experiment, you remove the viewfinder, and instead you ask subjects to reach in through a hole. I'm just going to stick it here, but it's actually under the box. Reach in through a hole under the box and feel the object with their hands. And then the experimenter asks, which of the things I'm holding matches what you feel? And unsurprisingly, subjects say the square. They're feeling a square. And unsurprisingly, they say it feels like a square. And again, if you have subjects draw things in this condition, they draw a square. Now, in condition 3, you kind of put the first two conditions together, but in a particular order. So you say to the subject, I want you to look inside, and then after you're already looking at the object, I want you to reach under and feel it with your hand. So subjects go ahead and look in, and then after they look in, they reach under and feel it with their hand. Sorry, this got all screwed up here. I'm not sure why. And then the experimenter asks, which of my display matches what you feel? And again, you can have subjects draw this. We're just looking at this version of it. And here's the interesting part. Here's the interesting question. What is this person going to say? To her eyes, you would think the object is looking like this, while to her hand, you would think the object is feeling like this. So when asked what she feels, you might think she'll say this. Or you might think she'll object and say, well, it feels square, but I can see that it's rectangular, so something is off, or I can't really tell because it feels weird or something like that. But that's not what subjects do. Instead, the vast majority of subjects act just like they did in the first condition. They say, this one here matches what I feel. And if asked to draw, they'll draw something like this. Well, what does that suggest? It suggests that, in fact, what's happening to the eyes is influencing what the subject feels. Just like in the McGurk effect, what happens to the eyes influences how it sounds. The sound bat, bat, bat sounds like that bat, bat because you see the mouth moving. Similarly, in this experiment, the object feels rectangular even though it's square because of what's happening to the eyes, because it looks rectangular to the eyes. So let's look through the conditions. In this condition where you see but you don't touch, you judge rectangle. In this condition where you touch but you don't see, you judge square. And then in this condition when you see and then touch, you judge rectangle again, just like in the first one. Well, what's the experience like in the first condition? Presumably it's like this, otherwise you wouldn't say rectangle. What's the experience like in the second condition? Presumably it's like this, that is, it feels square. This isn't supposed to indicate looking, it's supposed to indicate the tactile experience. It feels square, otherwise you wouldn't say square. Well, what does it look like and feel like here? Well, presumably it looks the same. How about the feel? Well, subjects say rectangle when asked to report what they feel. And most don't report any contradiction between what they see and what they feel. You'd expect them to do that if they were really relying on vision. If it felt square, but they said rectangle because they thought vision was getting it right. You would expect them to say, well, it feels rectangular. It feels square, but it looks rectangular, so I'm going to say rectangular. It's not what happens. Subjects just say it feels rectangular. So, presumably, it feels rectangular. Moreover, supporting this hypothesis, in a kind of fourth condition, it's not really an experimental condition because the experimenters didn't plan on it. They thought about it kind of after the fact. They begin the same way, have subjects look and feel and then say which of mine matches what you feel, and people pick the second tallest rectangle. And then the experimenter throws in a twist and says, now close your eyes. And how do subjects react? Well, they freak out. They say it's moving, or it just changed shape. Or they laugh, or they pull their hand away. Well, why is that? Well, suppose you're holding an object that feels rectangular to you, and then it changes to feeling square. It would have to seem to move in your hand. So subjects say the object seems to move in their hand because it really did feel rectangular. Despite being square, it felt rectangular. Just like despite the sound being bat, 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 you heard or it sounded to you like that fat bat because of how the mouth was moving, because you saw the mouth moving a certain way, and your brain used that information to decide the sound was that fat bat and make you hear that fat bat, make it sound like that fat bat to you. Similarly here, your brain uses the information coming to your eyes that the object is rectangular to make it feel rectangular to your hand. So when you close your eyes and that information is gone, and the information coming from your hand takes over, your brain is now going to make it feel square. And in order to shift from feeling rectangular to feeling square, it has to seem to move. That makes subjects freak out, retract their hand, scream, or whatever. Okay, so coming back here, we have the fact that subjects say it's rectangular, that they don't report any conflict between what they see and what they feel. And then in the condition we looked at just now, their reaction is just like the McGurk effect when you close your eyes. They report basically that what they feel changes when they close their eyes, which suggests that in the ordinary condition, when their eyes are open, when they're looking at the object and it looks rectangular, it also feels rectangular, which shows that the stimulus to the eyes is affecting tactile experience, is affecting how it feels. Okay, so back to the main dialectic. Cross-modal effects show, such as these, the McGurk effect and this Rock-Victor effect, show that it's not true that everything lines up neatly. Instead, what happens to your eyes can affect how things sound to you, and what happens to your ears can affect how things look to you. Now, of course, this doesn't happen directly. It's rather that there's communication between the parts of your brain that are processing the stimulus to your eyes and the parts of your brain that are processing the stimulus to your ears. Coming back here, how would we sort of indicate these effects? Well, we'd say, look, there's an arrow going from your eyes to auditory experience. It's not just your ears that affect auditory experience. And there's an arrow going from your eyes to tactile experience. It's not just your skin affecting tactile experience, affecting your touch experience. And those aren't the only two kinds of these effects. In fact, there's effects all over the place. I won't document them all here. I'll just mention a few. What happens to your skin can affect your visual experience. If you give subjects a single flash of light, say every 10 seconds or every 5 seconds, and ask them how many flashes there are, subjects will typically say there's one flash, and then 5 seconds later there's another flash, and then 5 seconds later there's another flash, and so on. But if you give 2 taps to their skin in sync with some of those single flashes, and only 1 tap in sync with others, on the times when you give one tap, they'll typically say there was 1 flash. But on the times when you give 2 taps, they'll typically say they saw 2 flashes. Or I shouldn't say typically say, but they'll far more often say they saw 2 flashes than they otherwise would. That suggests that the stimulus to the skin is affecting visual experience. There's also a sound-induced flash illusion where you do the same thing, except instead of tapping your skin once or twice, you play clicks in the ear. The motion bounce illusion, which we looked at in class, is also like this. When you have a click played to your ears, you are more likely to judge that 2 balls crossing paths are actually bouncing than when you don't have a click to your ears. There's also an experiment where showing from Brian Jick, showing that if you give puffs of air to someone's skin, they're more likely to judge a sound that is in fact ba to be pa. So you put headphones on a subject and you say, look, I'm going to play you a bunch of sounds. Each one's going to be either ba or pa, and I want you to tell me which it is. Well, subjects don't make very many errors. But then if you add a puff of air to their skin in sync with the sounds, when the sound is ba, they're more likely to say it's pa than they otherwise would be. And when the sound is in fact pa, played with the puff of air, they're even less likely to make an error and say it's ba than they otherwise would be, suggesting that the puff of air makes them more likely to interpret sounds as pa than as ba. There's also lots of experiments showing that what happens to the nose affects gustatory experience. This isn't because sniffing in affects how things taste so much as it is because air flowing out your nose from your mouth affects how things taste, radically affects how things taste, in fact. We can talk more about that in class. What happens to your eyes can also affect gustatory experience. There's all sorts of experiments like this, showing, for example, that if you eat Italian food off of a checkered tablecloth, you rate it as tastier than when you don't eat it off of a checkered tablecloth. We can talk about more of those examples in class. There's experiments showing that what happens to your nose can affect your tactile experience. So if you shoot into someone's nose a very woolly, like sheep type of scent, while they're feeling fabric, they'll judge the fabric as rougher than they would if you didn't shoot that sheep kind of scent into their nose. Whereas if you play a lemon scent or shoot a lemon scent into their nose, they'll judge the fabric to be smoother than they otherwise would. There's all sorts of effects going in every which direction here, lines being crossed every which way. Now here's an argument based on this fact. If perceiving is absorbing, then everything lines up neatly in the way we described before, in the way that table suggested. But it's not true that everything lines up neatly. That's what all of these cross-modal effects show. Therefore, perceiving is not absorbing. Now, there's an ambiguity here because we haven't said how often. It could say this: if perceiving is sometimes absorbing, then everything lines up neatly those times. It's not true that everything always lines up neatly, which means that sometimes perceiving is not absorbing. Or it could be like this: if whenever perceiving is absorbing, everything lines up neatly, things never line up neatly, so perceiving is never absorbing. Or it could be some percentage in between, just occasionally and all the time. So here's a question: is perceiving usually absorbing? Or do these effects just show that there are exceptions to the perceiving as absorbing view? Or do they suggest that perceiving is never absorbing? And next time we'll look at reason to think that these effects suggest that perceiving is never absorbing.